So the second problem I had assigned for homework was about this little particle who could. He was trying to move along the x-axis for what could be approximately either 6 seconds or 6 hours. They give you no units of time. And I forgot to mention in the last video, but 2011 and 2009 were both problem 1 that were assigned for homework. So that would mean that the calculator is active. So you certainly want to make sure that you're using a calculator on these two problems. There are some years where they are calculator active and some where they're not. It looked like for the past few years it's like every other year. So like last year I believe it wasn't calculator active, but the year before it was. So keep that in mind. We're definitely going to see enough examples that you're not going to have to worry about that too much, but let's go over the little particle that could. So this function, certainly look at that velocity function. It's nice to have a calculator for that. They give you the velocity and they give you the acceleration and they give you an initial condition at x of 0 equaling 2. So that initial condition in these things could either play out in finding the position formula, which is what will be tested this year, or an accumulation problem. And I believe, if I'm looking, I'm going to sneak peek at the guidelines. Yeah, so here it turned out to be an accumulation issue, but it could be how you find the initial position function. Okay, so part A said, is the speed of the particle increasing or decreasing? So anytime we see this, we need to compare velocity and acceleration. So this was pretty straightforward. They gave you velocity, so make sure you put that in y1 and acceleration in y2, and plug in 5.5 into your table, and you should get these two negative decimals. And so because they have the same sign, that would mean that it's speeding up. So this is something certainly that could be tested this year. They really were looking for a conclusion with reasoning. So I do think it's important that one, you show what V of 5 and A of 5 is, and then of course that we have the same sign. So that's two easy points right there. Part B says find the average velocity. So this could still be tested, but this is going to be tested if given position. And I think in this case it's actually x of t. I shouldn't be using s of t. They don't give position here, so because you don't have position, that makes this an average height problem. And so part B is out, even though that would have been a pretty easy win for us. That would have been nice 4 points for all of us, right? Finding the total distance traveled by the particle. Given velocity and total distance, we can't do that either. That is an integration problem. You could do it if you had to find, like if you had position, you would just have x of 6 minus x of 0, which would make sense because isn't that what this really equals? But since we don't have position, we can't do that. Okay, so part C is also out. Part D says the particle changes direction exactly one time. Find the position of the particle at that time. So this you could do. You could set the derivative equal to 0. I'm sorry, you could set velocity equal to 0, which would be position 0. And it is at one time, right? Exactly one time that happens. And so, oh, hold on, no we can't because it's integration. V of t changes from positive to negative, which means it changes direction exactly one time. And so then you would just take your initial, that would be your s of 0, plus the integration of your time, whatever this t equals of v of t. And that would give you the time and the position of the particle at that time. All right, so in terms of grading this thing, I think the only thing we have here is 2 solid points from part A. Keep in mind what I said about part C though. If you were given position, you could find its distance traveled. And then of course this would be, important in terms of like total distance traveled, or if it was displacement, you can find displacement given the position function. Okay, that's it.